In the real number system, squaring any number always produces a non-negative result. For example, 2 squared equals 4, and negative 2 squared also equals 4. This means there is no real number whose square equals -1. To overcome this limitation, mathematics introduces a new number called I, defined as I is the square root of -1. To represent this new number, we extend the one-dimensional number line into a two-dimensional coordinate system called the complex plane. The horizontal axis represents real numbers, while the vertical axis represents imaginary numbers. In this system, 1 lies on the positive real axis. -1 lies on the negative real axis. I lies on the positive imaginary axis. And -I lies on the negative imaginary axis. Multiplication by the imaginary unit I can be understood geometrically as a rotation. Specifically, multiplying a complex number by I rotates it by 90 degrees counterclockwise about the origin. Starting from the point 1, 0. Multiplying by I moves it to 0, 1, and multiplying by I again rotates it further to -1, 0. Applying the rotation twice results in a total rotation of 180 degrees. This corresponds to a half turn on the complex plane, mapping the point 1, 0 to -1, 0. Thus, the algebraic identity, I squared equals -1, can be interpreted geometrically as two successive 90-degree rotations. This rotational interpretation extends naturally to higher powers of I. Each multiplication by I corresponds to an additional 90-degree rotation. I to the first power, 90 degrees. I squared, 180 degrees. I cubed, 270 degrees. I to the fourth power, 360 degrees, returning to the original position. This shows that multiplication in the complex plane involves both scaling in magnitude and rotation.